Welcome everybody. This is the first class on integration. I will be starting off with basics and then slowly gravitating towards higher intensity problems. Now this particular course on integration is very important for any science and engineering. Suppose you want to get into any streams in science or any streams in engineering, integration is the integral part. Now more specifically, if you want me to correlate the benefits of studying integration to the existing scenario, then fields like data sciences, data analysis, machine learning, financial engineering, all of these areas require integration. So that is for the motivation for this subject. So having mentioned that, let me start off by giving the formulae. These are the important formulae that you will have to know. The first one is integral x raised to the power of n dx. This is equal to x raised to the power of n positive 1 divided by n positive 1, positive arbitrary constant. Now this is called as arbitrary constant. Now if you do not place this arbitrary constant and you have just placed this value, the solution is considered incorrect. In other words, the solution is not complete, so you will not be awarded full marks if you miss this. Some of the professors or lecturers, they are very strict. The minute they see that you have missed the C, they will simply mark it wrong. So this arbitrary constant is important. So let me move on to the next formula. Integral dx over x, this is equal to ln, you need to place this modulus of x in this fashion, ln of modulus x, because ln is only defined for positive values and it is imperative that this quantity is positive, so the modulus sign is important. Now if you do not place modulus, again you will be marked wrong. So question number 3, or I would say formula number 3, integral e raised to the power of x dx is equal to e raised to the power of x positive arbitrary constant c. Now let me draw a line and put in 4. Integral a raised to the power of x times dx. This is equal to a raised to the power of x over ln a positive arbitrary constant c. This is a very important formula. Formula number 5, integral of sin x dx. This is equal to negative cos x positive arbitrary constant c. Now some of you would slip or skip this sign. If the sign is missing, your solution is wrong. So have that in mind. Question number or formula number 6 is integral cos x dx is equal to sin x positive c, arbitrary constant c. Formula number 7, this is going to be integral of secant squared x dx is equal to tan x positive c, and let me place formula 8 there. Integral of cosecant squared x dx is equal to negative cot x plus c, and 9, integral of tan x dx is, now this is a very important formula. Now let me just show you. I know that integral of tan x is sin x divided by cos x dx. Now if I want to integrate this quantity, I will use the technique what is called as technique of substitution. So what do we do here? We take cos x to be equal to t, we differentiate cos x, we get differential of cos x is negative sin x dx. This is equal to dt. So sin x dx is negative dt. So if I were to substitute that value, this is going to be, in place of sin x dx, I substitute negative dt. In place of cos x, I substitute t. If I were to integrate this, I get negative ln t. Now you might be asking me, okay, I will just place negative ln of modulus of t, and then I will say negative ln of, now I'm removing this modulus sign, and then I would be placing cos x. The fact that I'm able to remove, because we are not dealing with definite limits, we are only dealing with indefinite limits, so that gives me that extra privilege of removing it. Of course, it is a good practice to write it in this fashion, ln of modulus of t. That conveys to the examiner that you know the concepts well. Now this is negative ln of cos x, and what you can do is you can retain the modulus. Just to be consistent, I will just retain the modulus sign, and then I will place the arbitrary constant c. So that is the solution for integral of tan x dx. Now if I were to extend this line and then go up to formula number 10, I've got what is integral of cot x dx. Now this is going to be ln of sin x plus arbitrary constant c. Now if you want me to show you how it is done, now cos x is nothing but cos x over sin x times dx. Now let me take the substitution of sin x being equal to t. I differentiate, I get cos x dx is equal to dt. Now if you were to substitute that, cos x dx, I get dt over t, and this is going to be ln of modulus of t, which is nothing but ln of modulus of, my value of t is sin x, so that's why I get ln of modulus of sin x plus arbitrary constant c. So that's why we got that value. Now the next one, question, or I would say formula number 11, integral of secant x. This is a very important formula. Secant x dx is equal to ln modulus of secant x positive tan x positive arbitrary constant c. We will see how to get these things. And integral of cosecant x, this is also a very important formula. Cosecant x dx is equal to ln modulus of cosecant x negative cot x positive arbitrary constant c. Now having given you 11 and 12, let me also squeeze in 13. Integral of secant x tan x. Secant x tan x dx is equal to secant x plus arbitrary constant c. So that is also a very important formula. Now having given you this, let me move on to give formula number 14. This is going to be 14, integral of cosecant x cot x dx. This is equal to negative cosecant x positive arbitrary constant c. So I have given you 14 formulae over here, and after these 14 formulas, let me just flip the page and give you the other set of formulas too. Now this is number 15, integral of dx divided by square root of a squared negative x squared is equal to, very important, sine inverse of x over a positive arbitrary constant c. Number 16, integral of dx divided by a squared plus x squared is equal to 1 over a tan inverse of x over a positive arbitrary constant c. Now you need to know that over here we don't have any 1 over a being multiplied, but over here we got 1 over a, so exercise some caution. Formula number 17, integral dx over x times square root of x squared negative a squared is equal to 1 over a secant inverse of x over a positive arbitrary constant c. So I will be stopping here as far as the formulae are concerned. I will be stopping here, and then I think this is sufficient. So I have given you 17 formulae, and with these 17 formulae we will be able to handle things. So let me just move on to do questions, problem solving. Now imagine you have integral x to the power of 3 positive x to the power of 5 times dx. So how do you integrate this? Now first you need to distribute this. So this is equal to, when I say distribute, I am distributing the operator dx. So this is x to the power of 3 times dx positive x to the power of 5 times dx. Now I have given you a formula that x to the power of n, integral x to the power of n dx is x to the power of n, or I would say x raised to the power of n positive 1 divided by n positive 1, positive arbitrary constant c. So by this formula, this is going to be x raised to the power of 3 positive 1 divided by 3 positive 1 positive x raised to the power of 5 positive 1 divided by 5 positive 1. This is equal to x raised to the power of 4 over 4 positive x raised to the power of 6 over 6. Now you add the arbitrary constant. Okay, so that's the first question. Now question number 2. Imagine you have something like this: 1 over x to the power of 3 positive 1 over x to the power of 7 times dx. How do you integrate this? Now this is return, distribute dx, so this is going to be dx over x to the power of 3 positive dx over x to the power of 7. Now bring this to the numerator, so this is going to be x to the power of negative 3 times dx positive x to the power of negative 7 times dx. Now this is rewritten as a, now you can use the concept of integration. Now since we know that x to the power of n dx, integral x power n dx is x to the power of n positive 1 divided by n positive 1 positive arbitrary constant c. So by that, this is going to be x to the power of negative 3 added with 1, negative 3 added with 1, negative 7 added with 1, negative 7 added with 1. So this is x to the power of negative 2 over negative 2 positive x raised to the power of negative 7 over negative 7. Bring this negative 2 down, x raised to the power of negative 2 down, so that's going to be 1 over x raised to the power of 2. You have a 2 there with a negative sign, and similarly you bring this x raised to the power of negative 7 down, so it becomes positive, you got a 7 there. Now you can rewrite this by taking a negative sign out, so 1 over 2 times x squared positive 1 over 7 times x power 7 positive arbitrary constant c. So this is a lovely question that is important in understanding how we can deal with quantities when they are in the denominator. So let me move on to the next question. Now let's do this question. Suppose we are asked to integrate integral tan squared x dx. How are we going to do this? Now we know the trigonometric identity secant squared x negative tan squared x is equal to 1. So from here I can write secant squared x negative 1 is equal to tan squared x. So if we were to substitute that, this is going to be secant squared x negative 1 times dx, and this is equal to integral secant squared x dx negative integral dx. Now we know a formula. What do we know? Integral of secant squared x dx is equal to tan x positive arbitrary constant c. So if you were to substitute that, this is going to be tan x. You don't have to place the c as of now. Integrate this. This is going to be integral of dx will give you x. You rewrite this as tan x negative x positive arbitrary constant c. So that is the solution for this question. So you can just go through this and see if you're able to understand. Okay, so that is the complete working. Now I will go on to the next question. Now this question is a little bit challenging. Divided by 1 negative cos x times dx. So this is the way they will ask the questions, because all the time the questions will not be simple. Now what I'm going to do is I will also put in some other integral questions in this video lesson. Now it will be placed as a link. So what I would like to suggest you all is that go up to that questions also and look at them. Now we know a trigonometric identity. Cos 2x is cos squared x negative sin squared x. This is one trigonometric identity. So using the formula, we can rewrite cos x negative cos 2x over 1 negative cos x times dx as integral cos x negative This is cos squared x negative sin squared x divided by 1 negative cos x times dx. Now I'm going to take or distribute the negative sign, so it's going to be cos squared x positive sin squared x times dx divided by 1 negative cos x. So this is equal to, let me take cos x out. So I will get 1 negative cos x over here. Now I want to write sin squared x as 1 negative cos squared x divided by 1 negative cos x. Now 1 negative cos x can be taken out common. This is giving me cos x. Now 1 negative cos squared x is 1 negative cos x times 1 positive cos x. So that would mean I have taken 1 negative cos x out, so I would have 1 plus cos x divided by 1 negative cos x. So this is the quantity that I have got. So 1 negative cos x, 1 negative cos x can be cancelled, giving me, I add these two things, so 2 times cos x positive 1 times integral dx. If you have to integrate this, this is 2 times cos x times dx positive integral dx. Integral of cos x is sin x, positive integral of dx is x, and you can rewrite it as 2 times sin x, positive arbitrary constant c. So this is a lovely question. Why is it a lovely question? If you do not break it out like this and then make the following substitution, this can turn out to be really a challenging question. So having given you this beautiful solution, let me move on. This is an interesting question, and we need to approach this question with a little bit caution. Now I want to get the denominator featured in the numerator. So for that, what I'm going to do is I'm going to add a 1 and take that 1 out. So this is going to be 1 followed by a negative 2, and that in turn would give me the numerator. Negative 1 should be there. So 1 added with negative 2 would give me negative 1 divided by x to the power of 2 positive 1. Now I would like to club x power 6 positive 1 together and leave the 2 out and rewrite it in this fashion. Then I would like to rewrite this as x to the power, can I write it as x squared raised to the power of 3 positive 1 followed by a negative 2 divided by x squared positive 1 times dx. Of course, because a raised to the power of n raised to the power of n, m is a raised to the power of n times m. So this is going to be x power 6. Now this term x squared raised to the power of 3 positive 1 is nothing but a cubed plus b cubed. Now a cubed plus b cubed has a formula. A cubed plus b cubed will give me a positive b times of a squared negative ab positive b squared. So this is going to be, in place of a I got x squared, and in place of b I got 1. So if you had to substitute this is a formula. This is going to be giving me, so this is x squared raised to the power of 3 positive 1. This can be rewritten as x squared positive 1 times x squared raised to the power of 2 negative x squared times 1 positive 1 raised to the power of 2. So this is going to be x squared positive 1 times x to the power of 4 negative x squared positive 1. Now take this and substitute it in the quantity that we have here. So therefore x to the power of 3 raised to the power of 3 positive 1 negative 2 divided by x squared positive 1 times dx. This is actually rewritten x to the power of 2 raised to the power of 3 positive 1 divided by x squared positive 1 times dx negative 2 times integral dx divided by x squared positive 1. Now this quantity which you see has been evaluated, has been shown. So this is nothing but x squared positive 1 times x to the power of 4 negative x squared positive 1 divided by x squared positive 1 times dx negative 2 times integral dx over x squared positive 1. So x squared positive 1 x squared positive 1 goes off, giving x power 4 negative x squared positive 1 times dx negative 2 times integral dx over x squared positive 1. if you were to integrate this, this is going to be x power 4 times dx negative x squared times dx positive integral dx negative 2 times dx over x squared positive 1. This upon integration will give you x power 5 divided by 5 negative x power 3 divided by 3 positive x negative 2 times integration of this is going to be tan inverse of x over a is 1. Rewriting this, you would give me x power 5 divided by 5 negative x power 3 divided by 3 positive x negative 2 times tan inverse of x positive arbitrary constant c. So that is the solution for the question integral x power 6 negative 1 divided by x squared positive 1 times dx. Right, this solution is present over here. So we'll move on to the next one. First we will see how to integrate integral x squared over 61 x squared positive 1 times dx. Now foremost what I wish to do is I would like to multiply the numerator by 61 and divide it by 61. So this is 61 x squared positive 1 which is given already in the denominator. So what I'm doing is just this quantity. This is not going to change the integral at all. We will still have the original given question. Now what I would like to do after this, I would like to add a 1 here and take away a 1. This also will not change the integral. So this is what we have got. Now what I wish to do is I would like to rewrite this as 1 over 61 integral 61 x squared positive 1 times dx. I'm distributing dx divided by 61 x squared positive 1 followed by a negative sign 1 times dx divided by 61 x squared positive 1. So this is what we have got. Now this and this can be cancelled, giving you 1 over 61 integral dx. Over here we need to perform some operations that would ensure that we are able to integrate this quantity. So what is that going to be? Now to solve this, what I wish to do, I would like to take 61 out. So if I were to take 61 out, this is going to be 1 over 61. In the numerator you have dx. This is going to give me x squared positive 1 divided by 61. 61 times x squared will give you 61 x squared. 61 times 1 over 61 will give you 1. Okay, now take this part alone. Consider integral dx divided by x squared positive 1 over 61. Now what I wish to do, I would like to write 1 over 61 as 1 over root of 61, and this entire quantity is raised to the power of 2. Now what is this? This is similar to integral dx over x squared positive a squared, which has got a formula 1 over a tan inverse of x over a positive arbitrary constant c. So if I were to use this formula to rewrite this, this is going to be 1 over, this entire component is a. So a is 1 over root 61. That is multiplied by tan inverse of x divided by my a is 1 over root 61. Now this can be rewritten as root of 61 times tan inverse of root, you flip this is going to be root of 61 times x positive arbitrary constant c. This is what you will get. Now take this and substitute it here. So this is going to be 1 over 61. Integral of dx is x negative. There is already a 61 there, place that, and now you place this component. What is that? This is root of 61 times tan inverse of root of 61 times x, and we will have to rewrite this. You can rewrite this as x over 61 negative 1 over 61 squared times root of 61 times tan inverse of root of 61 times x positive arbitrary constancy. So this is a beautiful question. Integrate 15x to the power of 3 negative 1 divided by x times 15x cubed positive 1 and the differential operator. Now we are expected to integrate this. Now let me take this to be as I. Now this is a challenging question. If you are not in a position to split this, now you can split it in many different ways, but splitting is important. Now how do we split? You have to split in other words, you got to be in a position to write the numerator in terms of the denominator. Only then this question is solvable. If not, it will take ages. So having mentioned that, I want to bring 5x to the power of 3 positive 1 over here in the numerator. So for that, what I wish to do is, I'm going to rewrite 15 as, say, 20x to the power of 3, and then I will subtract from 20x to the power of 3 5x to the power of 3. Now when I subtract 5x to the power of 3 from 20x to the power of 3, I am getting 15x to the power of 3. Fine, but I need to have a negative 1, so for that just place a positive 1 there. Now this is how you write the numerator in such a fashion that you have this term as one of the terms in the numerator. So this is divided by x times 5x to the power of 3 positive 1. This is what we have got. Now what I wish to do is I would now like to rewrite this by algebraic split. In other words, if you have a positive b divided by c, you can write it as a over c positive b over c. So by this can be rewritten as 20 times integral x to the power of 3 divided by x times 5x to the power of 3 positive 1 times dx, followed by negative integral 5x to the power of 3 positive 1 divided by x times 5x to the power of 3 positive 1 times dx. Now this and this gets cancelled, giving you negative integral dx over x, so this is simple, and this and this gets cancelled, giving you 20 times x to the power of 2 times dx over 5x to the power of 3 positive 1. Now let me consider this term. Consider x to the power of 2 times dx divided by 5x to the power of 3 positive 1. So I'm going to take, let 5x to the power of 3 positive 1 be equal to sum t. So if you want to differentiate this, is going to be 5 times 3 times x to the power of 2 times dx is equal to dt. So I've got only x squared dx. So you remove this 5 times 3, 15 to the right side. So x squared times dx is equal to dt over 15. So take this and substitute it here. So this is equal to 20. In place of x squared dx, I'm going to substitute dt divided by 15 over 5x to the power of 3 positive 1 is taken to be as t negative integral dx over x. So this is equal to 5 can divide here 3 times, 5 can divide 4 times, so 4 over 3. Integral of dt gives me ln t, integral of dx gives me ln x. So this is equal to 4 over 3. My t is 5x to the power of 3 positive 1, right? Substitute that, negative ln x. Since it's indefinite integral, you need to place the arbitrary constancy. So this is the solution. Now most of the times we know in this case that the value of x should have to be positive. So for that case, in this case, since the degree of x is odd power, it is important that we place the modulus sign. So that is the final step. It's an icing on the cake, and it is necessary that we place the modulus. So having mentioned that, this completes the solution for this question. Integral dx divided by 1 positive e raised to the power of 81x. So don't be intimidated by these numbers over here. Now, first, what I wish to do is, I would like to multiply. Let me rewrite this as 1 over 1 positive e raised to the power of 81x. I'm going to multiply the numerator by e raised to the power of negative 81x and e raised to the power of negative 81x. The numerator and the denominator are multiplied by e raised to the power of negative 81x. The the differential operator has to be placed. Now if you push in this is going to give you integral e raised to the power of negative 81x divided by this is multiplied with e raised to the power of negative 81x. So this is going to give me e raised to the power of negative 81x. Now this is actually e raised to the power of x multiplied with e raised to the power of negative x, which is nothing but e raised to the power of x added with negative x. So that's going to be negative x here. Positive x, negative x gets cancelled, giving you e raised to the power of 0, which is nothing but 1. So you will have a 1 there. Fair enough. Now what I wish to do is I would like to make the substitution as follows. Let me take 1 positive e raised to the power of negative 81x to be equal to some u. I am differentiating 1, I get 0. If I were to differentiate this, I would get e raised to the power of negative 81x multiplied with the coefficient of x, which is negative 81, times differential operator is equal to du. Now this can be further rewritten as e raised to the power of negative 81x times dx. I don't have a negative 81 in the numerator, so push it down. So this is going to be du over 81 with a negative sign. Take this quantity and place it over here. So this is equal to negative du divided by 81. So I'm going to write this as follows: 1 over 81 with a negative sign divided by 1 positive e raised to the power of negative 81x is u. So this is going to be negative 1 over 81 integral of du over u. This has to be written as ln u. Do not write log, write it as ln. Now u, what is u? This is nothing but 1 over 81 times ln of, in place of u, you substitute this value, 1 positive e raised to the power of negative 81 times x, positive arbitrary constant. You need to add this arbitrary constant. If you don't add this arbitrary constant, it is considered as incomplete. Some professors would award you with the penalization. Some professors would outrightly mark it as wrong, because this is very important. And you might be wondering why is just an arbitrary constant. Yes, it is an arbitrary constant, but this constant will play a vital role in several of the systems that you will be studying in the field of engineering and technology. How to integral 1 positive sin x over 1 negative sin x times dx. So first what I wish to do is I would like to multiply the numerator and denominator by 1 positive sin x times, of course dx is the operator, so 1 positive sin x in the numerator and 1 positive sin x in the denominator. So this is going to give me 1 positive sin x raised to the power of 2. Now a negative b times a positive b will give me a squared negative b squared. So this is going to be 1 negative sin squared x times dx. But 1 negative sin squared x is cos squared x, so I can substitute that. So I'm going to be integral 1 positive sin x raised to the power of 2 divided by cos squared x times dx. Now let me expand this 1 positive sin x raised to the power of 2. That's going to be 1 positive 2 times sin x positive sin squared x divided by cos squared x times dx. Now let me rewrite this as 1 over cos squared x positive 2 times sin x cos squared x positive sin squared x over cos squared x times dx. Now this is equal to, now 1 over cos x is secant x. So 1 over cos squared x is going to be secant squared x. So this is going to be secant squared x dx positive 2 times sin x over, this is sin x over cos squared x. So I can rewrite this as sin x over cos x multiplied with 1 over cos x, right? Which is nothing but tan x times secant x. So this is tan x times secant x times dx plus integral sin x over cos x is tan x, but sin squared x over cos squared x is going to be tan squared x times dx. So this is going to be integral of secant squared x would be tan x, 2 times integral of secant x tan x is going to be secant x, and integral of tan squared x, I'm going to write tan squared x by this formula, secant squared x negative tan squared x is equal to 1. So secant squared x negative 1 is equal to tan squared x. So this is going to be secant squared x negative 1 times dx. So this is tan x plus 2 times secant x plus integral secant squared x dx negative dx. So this is equal to tan x plus 2 times secant x. Integral of secant squared x is tan x. Integral of dx is x plus arbitrary constant c. However, you can add these two. This is going to give me 2 times tan x plus secant x negative x plus c. You can take 2 out and you can write this as tan x plus secant x negative x plus c. So this is the final answer for this question. We expected to integrate integral root of x positive root of x squared positive 3 times dx. Now it is imperative to understand integration of this nature are always asked for high level entrance exams and scholarships exams. So it is imperative that you learn how to handle such questions. So having given you this question, let me just get it started. So first what I wish to do is I would like to make the following substitution. Let x positive square root of x squared positive 3 be equal to some u. So I'm going to rewrite this as root of x squared positive 3 is equal to u negative x. Then I will be squaring both sides. So square both sides, you get root of x squared positive 3 raised to the power of 2 is equal to u negative x raised to the power of 2. Expand this, you get u squared negative 2 times u times x positive x squared. You expand, you square this, the square root and the square gets neutralized, giving you x squared positive 3. X squared gets cancelled. Now what I wish to do is I would like to move this u squared to this end and I get a quantity like this. Then I wish to bring in negative 2 times u down, and then I would like to take a negative sign out and then rewrite x. Negative will become positive, so therefore x is equal to u squared negative 3 divided by 2 times u. This is what we have got. Now I'm going to get dx, so differentiating both sides we get. For this I will be employing u over v form. So differential of x is going to be dx. This is going to be 2 times v times differentiation of u squared negative 3 is going to be 2 times u times du followed by negative u squared negative 3 differentiation of 2 times u is going to be 2 times du divided by 2 times u raised to the power of 2. Now du is common, so you can take it out. Now this is going to be 2 squared u v negative of 2 times u squared negative 3 times du divided by 2 squared and u squared. Now this can be further rewritten as 2 times u squared u into, now this is actually u, right, because 2 times u, I'm just taking it as v, it's u. So this is going to be 2 squared times u into u is u squared negative 2 times, so if I have a positive b divided by c, I'm going to write it as a over c positive b over c. So this is going to be 2 times u squared divided by 2 squared u squared negative 2 times of u squared negative 3 divided by 2 squared u squared times du. Now this is equal to, right, so now clearly you can see that the 2 squared and the u squared they can get cancelled, so giving you 1 negative over here, a 2 and a 2 gets cancelled, so it's going to be 1 negative u squared negative 3 divided by 2 times u squared. times du, and this is going to be my dx. So this is what I've got. So therefore integral root of x positive root of x squared positive 3 times dx is equal to integral, in place of x positive root of x squared positive 3 you can substitute u, right? U is substituted, and in place of dx I can substitute 1 negative of u squared negative 3 divided by 2 times u squared times du. So this is going to be u raised to the power of 1 over 2. I'm just distributing the value times u raised to the power of 1 over 2 times u squared negative 3 divided by 2 times u squared times du. So this is what you've got. Now this can be further rewritten as integral u raised to the power of 1 over 2 times du negative. Now 1 over 2 can be taken out. Now push this 2 to the numerator, so it's going to be 1 over 2 negative 2 times u squared negative 3 times du. So this is going to be integral u raised to the power of 1 over 2 du negative 1 over 2. Now distribute u raised to the power of 1 over 2 negative 2 times u squared. So that's going to be u raised to the power of 1 over 2 negative 2 positive 2. Distribute this, is going to be 3 times u raised to the power of 1 over 2 negative 2 times du. Now this can be further rewritten as u raised to the power of 1 over 2 times du negative 1 over 2. Now negative 2 positive 2 goes off, giving you u raised to the power of 1 over 2. Of course du is there, so you can substitute du there, I should say place du there. So now if I were to bring this negative inside, it will become positive. So it's going to be positive 3 over 2 times integral. Now if you were to simplify this, that's going to be 1 negative 4 divided by 2. That's going to be u raised to the power of negative 3 divided by 2 times du. So this is what you've got. Now what you can do is you can directly integrate this. Now what I want to do is I actually want to take u raised to the power of 1 over 2 and then simplify it, but it's okay, you can just directly integrate this. So this is going to be u raised to the power of 1 over 2 positive 1 divided by 1 over 2 positive 1 negative 1 over 2 u raised to the power of 1 over 2 positive 1 divided by 1 over 2 positive 1 plus 3 over 2 u raised to the power of negative 3 over 2 positive 1 divided by negative 3 over 2 positive 1. Now let me go to this side of the page. Okay, so I can rewrite this as u raised to the power of 3 over 2 divided by 3 over 2 negative 1 over 2 u raised to the power of 3 over 2 divided by 3 over 2 positive 3 over 2 u raised to the power of, this is going to be negative 1 over 2 divided by negative 1 over 2. Now I'm going to take u raised to the power of 3 over 2 out, so it's going to be 1 over 3 over 2 negative 1 over 2 times 1 over 3 over 2 followed by 3 over 2. You flip this, you get negative 2 over 1, and this is going to be u raised to the power of negative 1 over 2. So this is equal to u raised to the power of 3 over 2. You flip this, you get 2 over 3. In fact 2 can be cancelled, giving you 1 over 3, and over here 2 can be cancelled, giving you negative 3 u raised to the power of negative 1 over 2. So this is equal to u raised to the power of 3 over 2. 3 is the LCM. 2 negative 1, it's going to be 1 over 3 negative 3 u raised to the power of negative 1 over 2. So if you have to rewrite this, this is u raised to the power of 3 over 2 divided by 3 negative 3 times u raised to the power of negative 1 over 2. Now but my u is x positive root of x squared positive 3, right? So if you have to substitute that, this is going to be, in place of u, you substitute x positive root of x squared positive 3. This is raised to the power of 3 over 2. You got 1 over 3 there, negative 3 times. Now you can push this u down. So it's going to be root of, let me just take it like this, x positive root of x squared positive 3 raised to the power of 1 over 2. This is what I've got. Now what you can do is you can take the LCM. If you were to take the LCM, this is going to be x positive root of x squared positive 3 raised to the power of 1 over 2. So you multiply this, you get x positive root of x squared positive 3. Of course there is a 3 there, so probably you can place a 3 there. So this and this, they get product multiplied, and when you multiply that, you get 3 over 2 plus 1 over 2. That's going to be a square there, right, negative, and that's going to be 9 there. So this can be further rewritten as x positive root of x squared positive 3 raised to the power of 2 negative 9 divided by 3 times root of x positive root of x squared positive 3 positive arbitrary constancy. Now this is the end of the solution. We expected to integrate this. Integral x raised to the power of 3m positive x raised to the power of 2m positive x raised to the power of m times 2 times x raised to the power of 2m positive 3 times x raised to the power of m positive 6, and the entire quantity is raised to the power of 1 over m. Now you can clearly see you got 3m and you got 2m, you got 2m, you got m here, and you don't have anything over here. When I say you don't have anything, it means you got x raised to the power of 0. That can be taken to be as 1. Now what I wish to do is I would like to change this to reflect this. In other words, I want the exponents to be as 3m, 2m and m. So how is that done? Simple. You just increment this by m. In other words, you multiply all these quantities by x power m and you divide by x power m. That's exactly what I'm going to do. So I'm going to multiply by x power m and I'm going to divide by x power m. This quantity 2 times x raised to the power of 2m positive 3 times x raised to the power of m positive 6 has to be performed within 1 raised to the power of m. So this operation is done inside this exponent multiplied with dx, and of course you got x raised to the power of 3m plus x raised to the power of 2m plus x raised to the power of m there. Now when x raised to the power of m goes inside, what happens here? This is nothing but 2 times x raised to the power of 2m multiplied with x raised to the power of m positive 3 times x raised to the power of m multiplied with x raised to the power of m positive 6 times x raised to the power of m divided by x raised to the power of m. As I mentioned to you, this entire component is raised to the power of 1 over m times dx. Of course over here you got x raised to the power of 3m plus x raised to the power of 2m plus x raised to the power of m. Right? Now we are going to use this formula, a raised to the power of m multiplied with a raised to the power of n is equal to a raised to the power of m positive n. Now in this case, x raised to the power of 2m multiplied with x raised to the power of m, this is nothing but x raised to the power of 2m plus m, right? So this is going to be 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m. This is raised to the power of 1 over m divided by x raised to the power of m raised to the power of 1 over m times dx. I can always write it like this, right? Okay, so this is multiplied with x raised to the power of 3m plus x raised to the power of 2m plus x raised to the power of m with the integral sign. Now m and m can be cancelled, and so I can push this x over here. So this is equal to integral x raised to the power of 3m plus x raised to the power of 2m plus x raised to the power of m divided by x. This is one term, and this is multiplied with 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m times dx. Now you have a law, a raised to the power of m divided by, say, a raised to the power of n. I can rewrite this as a raised to the power of m negative n from the law of indices. So in fact I can also use one more law. What is that? A plus b divided by c is a over c plus b over c. So every quantity is divided by x. So I'm going to rewrite this as x raised to the power of 3m divided by x plus x raised to the power of 2m divided by x plus x raised to the power of m divided by x times 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m times dx. Now you can, as I mentioned to you, you can push this index. So in that case this is going to be x raised to the power of 3m minus 1 plus x raised to the power of 2m minus 1 plus x raised to the power of m minus 1 times 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m times dx. So this is what you've got. Now what I wish to do is I would like to make a substitution. I'm going to the next page. What is the substitution I would like to make? I would like to make, let me have 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m. Let me take it to be equal to some t. So differentiating both sides, I would get 2 times 3m times x, 2 is already there, so place x raised to the power of 3m minus 1, right? Positive 3 times 2m times x raised to the power of 2m minus 1, positive 6 times m times x raised to the power of m minus 1 times dx is equal to dt. Now we will have to perform some simplification. So 2 into 3, 6 times m x raised to the power of 3m minus 1 plus 6 times m x raised to the power of 2m minus 1 plus 6 times m x raised to the power of m minus 1 times dx is equal to dt. Now what I can do is I can actually take 6m out. So 6m is taken out. I got x raised to the power of 3m minus 1 plus x raised to the power of 2m minus 1 plus x raised to the power of m minus 1 times dx is equal to dt. Right? Now I need only this quantity. So from here x raised to the power of 3m minus 1 plus x raised to the power of 2m minus 1 plus x raised to the power of m minus 1 times dx is equal to dt divided by 6m. Now clearly you can see I've got this term with dx. So I can always substitute that. So in place of this I'm going to substitute this dt over 6m. So this is equal to integral. I got a dt over 6m. So I'm placing a dt. I have a 6m here. In place of 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m, I'm going to substitute this t. So you got t there. Now 6m is a constant. Take that out. You got t times dt. You integrate that. You get t squared divided by 2, which can be written as t squared divided by 12 times m. But my t is this. So substitute that. This is equal to 1 over 12m times 2 times x raised to the power of 3m plus 3 times x raised to the power of 2m plus 6 times x raised to the power of m. This is raised to the power of 2. So place the 2 and place the arbitrary constant c, which is the final answer to this beautiful question. So this is a lovely question. I hope you enjoyed this. We are expected to integrate integral dx divided by sin x negative cos x positive root 2. Now this is the catch. We got a presence of root 2. So what I wish to do is I would like to rewrite this integral as integral dx over sin x times root of 2 divided by root of 2 minus cos x times root of 2 divided by root of 2 plus root 2. Now this can be further rewritten as, now this is equivalent to multiplying by 1, right? So 1 times sine x is going to give us sine x, so there isn't any change at all. Similarly, cos x times 1 is going to give us cos x. So just to get the result, I am manipulating the denominator in this fashion. So this is rewritten as, now you got root 2 and you have root 2 here. So what I wish to do is I would like to take the root 2 out. So this is integral dx over root of 2 is taken out. So this is going to give me sin x times 1 over root 2 negative cos x times 1 over root 2 positive 1. Now we know that sin 45 is equal to 1 over root 2. Now sin 45 can be rewritten as sin pi over 4. Also cos pi over 4 is going to be cos 45, and cos 45 is 1 over root 2. So I would like to utilize this result over here. So this is equal to integral, there is a root 2 there, I'm going to rewrite it in this fashion, dx divided by sin x times sin pi over 4 negative cos x times cos pi over 4 positive 1. Now we have studied an important formula. What is the important formula we have studied? Cos of a minus b is equal to cos a cos b positive sin a sin b, and cos of a positive b is equal to cos a cos b negative sin a sin b. Now is it okay if I rewrite it as negative sin a sin b? If you were to take the negative sign out, this is going to be negative of sin a sin b, and then I need to get a positive sign, so I had to place a negative sign. So this is going to be cos a cos b, right? I'm taking the negative sign out, so that would mean I have a sin a sin b negative, because negative into negative would give me positive, so that's the reason we are having a negative. So is it okay if I can rewrite this in this fashion? Of course. But what is actually we have done? We have actually rewritten our cos of a positive b in this fashion. So we have a result now. So what is the result? Negative of sin a sin b minus cos a cos b can be replaced with cos of a positive b, right? So we have a result. Now what I wish to do is I would like to take this negative sign out, so thereby we have sin a sin b negative cos a cos b is equal to, if you have to multiply by negative throughout, this will become positive, this will have a negative. So this is going to be negative cos of a positive b. So this is the result that I would be utilizing over here. So let me do that. So this is equal to 1 over root 2 integral dx divided by, in place of this I am substituting negative cos of a plus b. So in this case it's going to be x positive pi over 4, and you got a positive 1 over there. So this is what we have got. So now I can rewrite this as 1 over root 2 integral dx divided by 1 negative cos of x positive pi over 4. Now this is very similar to the formula which we have studied. Now if you remember, we know that 1 negative cos 2x divided by 2 is equal to sin squared x, and 1 positive cos 2x divided by 2 is equal to cos squared x, right? Now this can be further rewritten as 1 negative cos 2x is equal to 2 times sine squared x. So in place of 2x we have got this quantity. So let me go to the next page. So let me write that down. So we got 1 negative cos 2x is equal to 2 times sine squared x. But what do we have? We got in place of 2x I've got x positive pi over 4. So what is x? X is nothing but, bring this 2, you get 1 over 2 times x positive pi over 4. I can rewrite this as x over 2 positive pi over 8. So this is my value of x. So with this I can rewrite 1 negative cos of x positive pi over 4, this to be as 2 times of sine squared. In place of x I got x positive 2 positive pi over 8. So these are some of the simplification is actually required. So coming back, so therefore 1 over root 2 integral dx divided by 1 negative cos of x positive pi over 4 is rewritten. In place of this I would be substituting this. So that's 1 over root 2 integral dx divided by 2 times sine squared of x over 2 positive pi over 8. Now we know that cosecant x is equal to 1 over sine x. So cosecant squared x is equal to 1 over sine squared x. So this is equal to 1 over 2 times root 2 integral cosecant squared x, that's going to be cosecant squared x positive to positive pi over 8. So this is what times dx is what we have got. Now what I wish to do, I am going to make a following substitution. I am going to take, let x positive to positive pi over 8 be equal to u. So from here I get dx over 2 is equal to du. So therefore dx is equal to 2 times du. So substitute that. So 1 over 2 times root 2 in place of x over 2 positive pi over 8 I get u. So this is cosecant squared u. In place of dx you have 2 times du. So I'm going to place du here and I'll place 2 here. 2 can be cancelled, giving me 1 over root 2 integral cosecant squared u du. But what is cosecant squared u? Cosecant squared u is a formula, because we know that cosecant squared x dx is equal to negative cot x positive c. This is similar to integrating secant squared x dx, which is going to be equal to tan x positive c. Right? Differentiation of this would give me this back, the integrand back. Similarly, differentiation of this would give me the integrand back. If you want to see the proof how exactly you can integrate cosecant squared x dx to produce negative cot x, I will put the link there. You can watch that video also. So having got that, this is going to give me 1 over root 2 negative cot u. But what is my u? My u is this. Substitute that value. So 1 over root 2. Of course, take the negative sign out. So this is going to be cot of x over 2 positive pi over 8. And you can either hold here or you can remove the parenthesis and distribute negative 1 over root 2 inside. So if you were to do that, you get this to be as negative 1 over root 2 times cot of x over 2 positive pi over 8 plus arbitrary constant c. So this is the solution for this question. So this is a beautiful question that we have got. I hope you all enjoyed this video. Now we got a question, integral sine of 3x positive 2 times dx. Now what I will do, I will take 3x positive 2 to be equal to sum t. I differentiate this, I get 3 times dx is equal to dt. So from here dx is dt over 3. You substitute that. In place of 3x positive 2, you substitute t. In place of dx, you substitute dt over 3. Rewrite this as 1 over 3 integral sine t times dt. integration of sin t is negative cos t. You have this 1 over 3. You can rewrite this as negative 1 over 3 cos of c. This is the solution. Now suppose you have cos of 7x positive, say 91 times dx. How do you do this? I take, let 7x positive 91 to be equal to t. I differentiate, I get 7 times dx is equal to dt. So dx is equal to dt over 7. So if we were to substitute here, this is going to be cos of, in place of 7x positive 91, it's t. In place of dx is dt over 7. I can rewrite it as 1 over 7 integral cos t dt. Integrate cos t, you get sin t, you got 1 over 7. Now you have to substitute t. So this is going to be 7x positive 91 plus arbitrary constancy. Now there is a formula that you will have to know. Suppose you have integral f of ax positive b times dx, then this is going to be f of capital F actually means integration of this function, f of ax positive b, and add the arbitrary constant. So if you have to have a function like this, then that is nothing but integration of this quantity. That is what is presented here. So if the coefficient of x is a, you multiply by 1 over a. If the coefficient of x is b, you multiply by 1 over b. If the coefficient of x is alpha, you multiply by 1 over alpha. So that is the idea behind using the formula. Okay, so having mentioned to you, or having given you this is the first part of the class on integration. I will continue on with the second part. Thank you everybody. Please like, share and subscribe to our channel. Until we meet again.